So last video I talked about, as part of why critical race theory is anti-science, what the four main normative principles of science are. And that sparked a question from a viewer, and I think it's worth going into in sort of a series of videos. So let me talk about that, and we'll introduce this upcoming series on this channel that will go through the just general guiding principles with regards to scientific inquiry. So on the last video, why critical race theory is anti-science, I talked about the normative principles of science, the four main ones. There are more than that have been proposed, but the four main ones that have been accepted since the 1940s. The other, that prompted a question actually from a viewer who responded to me over locals that suggested, hey, can you give us a breakdown of sort of guiding principles for doing scientific inquiry in a way that would be good for middle schoolers and high schoolers. And I think I can try and do that. Here I will attempt to do that. But reading that, I realized, reading through some of them and reminding myself what some of these guiding principles were, I thought it would be a good idea to make it into a series of videos instead of doing just one here, because there are a lot of them and there's a fair bit of depth that you can go into to understand what those mean. What I have up here is actually from a book. It's chapter 3 in a book called Scientific Research and Education, and it is the guiding principles for scientific inquiry. And what this had to do with was, it was actually, the idea behind the book was actually here to provide guidance actually for, it was actually meant for teachers. This is cited in some of the stuff with the No Child Left Behind Act, and yes, I know No Child Left Behind was horrible, but the principles that they were trying to get across and teach there were correct, as far as I could tell, with respect to how scientists approach doing inquiry. And so it's fair to say here that you can get into that. So I'm going to just lay out in this sort of intro video what those 6 principles really are. And these are different from the normative structure of, they're different and related, but related to the normative structure of science as a whole, science as a whole. But this is actually, when you're doing specific research, these are the things you need to do to make sure you're doing good research. That's different from science as a whole thing, where you are not just doing research, you are critiquing others at the same time. So that's why the norms and the norms of science and the guiding principles of scientific inquiry are a tiny bit different from each other. And I'll probably do a whole separate thing now that I've done the critical race theories anti-science. I'll probably do a whole separate series on just the norms of science, because I noticed there's nobody who can really break them down really easily. So I will endeavor to do that. But let's go down here to what those 6 norms are. And I'm going to borrow a bit from this book, actually, as I talk about the norms of science in other videos here. So let me go down to where those are. So yeah, political, and this is the thing, is that, and many will point you out, these 6 sort of guiding principles are fairly are applicable to all lines of science, really. Not just to physical sciences, not just to social sciences. They're applicable to all lines of sciences. And so that's why they're considered sort of guiding principles, as any scientific discipline makes use of these kinds of guiding principles for their inquiry in slightly different ways, because the nature of the field that you're studying and questions that you're asking are a little bit different, but the same ideas are there for these sort of guiding principles. There's not universally accepted, yes, that's true, but there's sort of 6 very interrelated principles here. First one is posing significant questions that can be investigated empirically. In other words, with respect to science thing, you want to pose a question that you can answer with some kind of data. With some kind of evidence, with some kind of empirical study that's grounded in real world observation, not some sort of ethereal, metaphysical, out there, something that's, you got to take it on faith or just on argumentation alone. No. This has to have evidence and data backing it up. You have to be able to investigate it empirically. Empirically, another word for empirically is with observations. Investigated with observation. Link research to relevant theories. So your question's got to be related to theories that have come before. And it may include you're proposing a new theory, but you're basing it off of something that's happened previously in the scientific world at this point. Use methods that permit direct investigation of the question. Okay. What the hell does that mean? So, direct investigation of the question, what we're talking about here is the method you use for research. Say you're asking a question. You don't want to use a method that doesn't answer that question, that doesn't provide you the data you need to answer that question. This gets into issues like correlation equal causation fallacies and things like that. I'm trying to think of a simple way to put this, but using methods that permit the direct investigation of the question. In other words, you're doing analysis that is directly related to the question you're asking. You're not doing analysis that's off over here and tangential to the question or completely unrelated. There are methods that are very specifically designed to answer that question that you're using. And often when it comes to peer review in academia and working with science, those are things that I critique really highly. I go after methods when I'm doing peer review. And if I don't think your method is answering the question you think it is, then I'm going to tell you so when I give you my reviews back. That's just simply the way it is. I mean, you can see the Nature Communications article. I pointed out to them right away, hey, you're starting off of a logical fallacy in here. But that's methods. Method section is like... I guess I'm trying to look for a good example with that, and I may come up with it in a later video, but it's method that permits direct investigation. Like I said, I'm going to expand upon each of these in a sort of series of videos. This fourth one, providing a coherent and explicit chain of reasoning. In other words, you got to be able to reason through your argument of why this happens and use your evidence to back it up. X happened because of Y, and this is the evidence for it. Y happened because of Z, and this is the evidence for that. And Z happened because of alpha, and that has the evidence for that. You have to get very explicit in your chain there. That's where the argumentation comes up when writing a scientific article. With this is that you have to provide the reasoning and have written out carefully what your reasoning is for why what you observed happened, why your theory, why your hypothesis put forward was correct, or also, why your hypothesis failed, what was new that you learned, and why do you think that it happened. You have to have a clear, very clear, explicit line of reasoning. You can't use implicit assumptions. This gets people a lot. You're not supposed to use a whole lot of implicit assumptions. And keep on going with that. Fifth one, replicate and generalize across studies. This is what people forget. People think one study and done. No. No. One study introduces this thing happens. You need to be able to replicate and do it over and over and over and over and over and over again. This is why reproducibility is such an issue in the sciences. It has to be something you can replicate. An experiment you can replicate over and over and over and over again and continue to get the same result. I think it was Einstein who once said replicating something many times, replicating the same process many times, expecting a different result is the definition of insanity. We're trying to make sure that we will continue to replicate the same result. We actually want to see that if somebody's hypothesis is to be elevated to the level of a theory, it has to be replicable many times, such that you can generalize it. Because one experiment provides you a specific instance of where that hypothesis works. But if you keep repeating it and keep going down the line, and the same thing keeps holding on true for a very long time with numbers of different experiments, that's when you can generalize something into a theory, more or less. Disclose research and encourage professional scrutiny and critique. So these things are this is related particularly to the communality and organized skepticism norms in particular here. There's going to be a lot of cross stitch. If you watch the other one where I kind of breezed over the norms a bit, you'll get some of the relationship here. Disclose research, encourage professional scrutiny and critique. You are supposed to be incredibly transparent as a scientist. You are supposed to publish everything. Data, methods, and what have you, and depending upon how you were funded to do your research, it might be legally required to do so. That's a thing with different governments who fund sciences. Some of them have mandated requirements that unless it's a matter of national security or has public health information, private health information in it, then you can't publish it. But everything else under the sun, you have to publish it. It has to be available publicly somewhere. Um, and it has to be open for professional scrutiny and critique. I coined a word, scrutique. It has to be open for professional scrutiny and critiques. You cannot sit on it. You cannot hide it. You cannot say, no, you can't critique this. No, you actually have to encourage people to critique it. That is one of the guiding principles there. I want you to critique my work. I want you to critique this video and tell me if I'm an idiot. I want you to critique all of my videos and tell me if they're idiotic. Go for it. I'm game. But you're supposed to be encouraging that. You're supposed to have professional scrutiny critique. And so that's generally it. I don't want to dwell too much on any one of them in this particular video because, like I said, I'm going to do a little series where I go through each of the 6 of these. And I think I'll follow on with a series about the norms also and add those in there because the norms of science as a whole are a little bit different because this is about research. This is about specific approaches. This is about approach to research specifically. So you can see these are getting very specific things. The norms are a bit more general to science as a whole. So I'm going to go through each of these separately in their own little video, starting from the top of this list and going to the bottom, and give you my thoughts on that. And we'll try and do that over the next week to 2 weeks. So keep an eye out. They will be coming out. So if you're looking forward to that and you like this video or any of my other videos, please subscribe to the channel, comment, let me know your thoughts. And I look forward to hearing from you all, and I'm hoping these little videos will be a fair bit shorter than other ones that I've done in the past. But I hope you all have been enjoying my content. Please let me know if there's anything you'd like to see. I am, of course, responsive to viewer requests for different information. I'm happy to do that, although otherwise I just like commenting on stuff myself and talking into a camera a little bit to share my ideas and thoughts with all of you. Anyway, that's it for now. Until next time, this is part 1 of the series on scientific inquiry. Part 2 will be on posing significant questions that can be investigated empirically. So I will see you all sometime soon. Until next time, this is Adrian, signing off. Stay curious, my friends.